Hello, good morning all. So today we will see the polynomial addition and the how can we implement the polynomial addition with the help of linked list. So basically these are the two polynomial 5x square plus 4x plus 2, and the second polynomial is 5x plus 5. The nodes of the polynomials are arranged in the decreasing order of their exponents. Similarly, the result will also be arranged in the decreasing order of their exponents. Okay, so initially we will make two pointers. The first pointer is pointing to first node of first polynomial, and the second pointer will point to the first node of second polynomial. Okay, and we will compare the exponent. If exponents are same, then we will just add the coefficient of that those two terms, and then we will include in the resultant part. Otherwise we will check which coefficient, which exponent is larger. Whichever exponent will be larger, with that term will be added in the resultant part, and corresponding pointer will get increased. The comparison will be starting from the first node of first list and first node of the second list, and comparison will be done only when some nodes are there in both of these polynomial. At some point of time, if one of the polynomial is get exhausted, then the remaining nodes of the second polynomial is completely copied as it is in the resultant, and like this we can implement the polynomial addition programs. The structure of the node is look like coefficient is added, coefficient is stored here, the data type of coefficient is considered as an integer, the power or exponent is there, the say it is also integer, and one pointer is there, structure pointer, which is pointing to the next node. So this is the structure of the node. Here we can see the algorithm for this. So we provide two lists. The first linked list is there, which is stored in P. P contains the pointer which is pointing to first node of first polynomial, and similarly Q is there, which is pointing to the first node of second polynomial. So set P and Q will point to the two first nodes. Here we are assuming that no header nodes are there in the linked list, and initialize the resultant linked list, and we will take the initially the linked list is set to null. That's why for that we will assume that initially no node is there in the resultant linked list. Okay, so this loop will get iterated while P is not equal to null and Q is not equal to null. What does it mean? It means that some nodes are already there in both of these polynomials, so that we can have a comparison. If one of the list is exhausted, then you just come out of this loop, and we will check which list is exhausted, and we will copy the remaining nodes of the of this second list in the resultant part as it is. Okay, then if in both of these lists some nodes are there, then we compare the exponent part of the nodes. So there are three possibilities. The exponent may be larger, the exponent of P may be larger as compared to exponent of Q. The second possibility, the exponent of Q is larger as compared to exponent of P. And the third possibility, exponent is same. Okay, when the exponent is same, then we will add the coefficient. Okay, so see the first possibility, when the exponent of P is larger as compared to exponent of Q, then what we will do, create a new node. Means we will allocate a memory for this, and we store the P in the resultant part. So P dot coefficient and P dot exponent will be stored in the newly created node, and we will increase this pointer. So insert at the end of the list R and advance this pointer P. So Q is not advanced in this. Then you come in the else if part, means this if condition is false, then you come here, and then we will check whether the exponent of Q is larger. If the exponent of Q is larger, then this is taken in the resultant part. Similarly, so create a node with storing Q dot coefficient and Q dot exponent in the newly created node, and this node is added at the last, and then increase this pointer Q. And the third possibility, when this condition and this condition is also false, then you come here, and then you will check whether the exponent is same. If exponents are same, then we will add the coefficient, provided the addition of this coefficient should not be 0. If the addition of this coefficient is 0, then we do not perform anything. Like suppose first node is suppose 4x and second node is minus 4x. Okay, so exponent is same, exponent is 1 in both of these cases, but when you perform addition of coefficient, then 4 and minus 4 will get you 0, and no need to do anything in this case. So if p dot coefficient and q dot coefficient is not equal to 0, then we will create a new node, and the exponent of this will be p dot exponent or q dot exponent, because they are same, but the coefficient will be p dot coefficient plus q dot coefficient. And in this case, when the exponent is same, then we will advance both of these pointer p as well as q. Likewise, we perform the addition, and then at some point of time any one of the list is exhausted, then you come out of this loop, then you will check which list is exhausted. If p is not equal to null, it means that second list is exhausted. Then copy the remaining term of p to the end of r. Otherwise, we will check if this condition is not true, it means that q is not equal to null, that is correct. Then we will check second list is not exhausted, then copy the remaining term of q to the end of r. Okay, it may also possible that both of these linked lists will exhausted at the same time. See this example. So you are at this point of time, you are at this node, and this is nothing but 2x to the power 0, and at some point of time you are at this node, this is 5x to the power 0. So exponent is same, that is 0. So you will perform this 2 plus 5, that is 7, and you will advance this pointer. Now this p is pointing to null, you will also advance this pointer, so q is also pointing to null. Okay, so in this case both of these linked list is exhausted at the same times. So this is the algorithm, and this is the corresponding program. So P1 is the first polynomial, P2 is the second polynomial, 3x to the power 3 minus 6x square plus 9x minus 10 is the first polynomial, 4x to the power 5, 3x to the power 3 minus 6x square is the second polynomial. The nodes are arranged in the decreasing order of their exponent. We will take two temporary variable, structure pointer, temp1 is equal to head1 and temp2 is equal to head2. Then we will take for resultant part head3, and it is initialized to null because no node is existing in this initially in this linked list. And we will take one more variable, that is previous. So previous is also is equal to head3 in the initial case, in the initial condition. Then we will take this kind of loop while temp1 is not equal to null and temp2 not equal to null. Then we will allocate the memory for this using malloc. Then we will check if temp3 is equal to null, it means that it is the first iteration of this loop. Then what we will do, head3 is equal to temp3. If this is not true, it means that it indicates the subsequent iterations of this loop. Then else is equal to, so one previous is there, so previous arrow link is equal to temp3 and temp3 arrow link is equal to null. Okay, so these two conditions will be made. At any point of time, previous contains the last node. Okay, so we will maintain the connectivity. So previous arrow link is equal to the newly created node, and the link part of newly created node will be set to null. Okay, so these are the two statements. And one more thing, after performing this, after attaching this temp3 as a last node, so we will update the previous. Okay, so your updated previous will be temp3. Now filling the data part of this in the temp3. So we will compare the temp1 arrow exponent and temp2 arrow exponent. So the similar three possibilities are there. If temp1 arrow exponent is larger, then we will take this node. So temp3 arrow exponent is equal to temp1 arrow exponent, temp3 arrow coefficient is equal to temp1 arrow coefficient, and so we are taking node from first list. So temp1 is increased, so temp1 is equal to temp1 arrow link. Okay, in the second possibility we will do exactly opposite of it. In the else part, we will check if temp1 arrow exponent and temp2 arrow exponent these are same. So just we come here, and temp3 arrow c is equal to temp1 arrow c, the coefficient will get added, the exponent will be temp1 arrow e, or we can also write temp2 arrow e because these two are same. In the third possibility, temp1 is also incremented and temp2 is also incremented. One more condition needs to be added here, that the addition of these two coefficient will not be 0. Like if we will write like this, if temp1 arrow c plus temp2 arrow c is not equal to 0, then we will perform this statement, otherwise we will not going to execute this statement. Okay, at some point of time you will come out of this while loop. After this while loop, we will check whether temp1 is equal to null or temp2 is equal to null. Then if temp1 is equal to null, it means that first list is exhausted. If first list is exhausted, then we will copy the remaining node of second linked list to the resultant part, and we will check if temp2 is equal to null. If temp2 is equal to null, it indicates that second list is exhausted. In that case, we will copy the remaining nodes of first linked list into the resultant part. Okay, so if temp1 is not equal to null, then while temp1, so we will just going to create the same thing. We will allocate the memory, copy the remaining node unless and until this temp1 become null, and if temp2, the similar thing can be performed here. So this is the program for the implementation of addition of two polynomials with the help of linked list. The time complexity for this algorithm or program is order of m plus n. The space complexity is also order of m plus n, where m is the number of elements in the number of nodes in the first polynomial, and n is the number of nodes in the second polynomial.